Okay, so continuing where we left off, we were talking about the perfect square pattern, and we're gonna go through now how to multiply them. Applying perfect squares. So what I mean is, you're going to be given something like this that's factored, and you're going to unfactor it. In other words, you're multiplying this out. Unfactoring. So let's say, example 1, x plus 3 squared. Now that means what you have to do, that's kind of in condensed form, right? You need to write it in expanded form first. So expand it. Remember, don't put a plus and a minus. It's x plus 3 times itself. On a perfect square, these two parentheses are exactly the same. Expand first. Okay. Then you're going to FOIL. So this is going to be x squared, outer is 3x, inner 3x, last 3 times 3 is 9, so it equals x squared plus 3x is 6x. Do not add the exponents. Plus 9. All right, pretty easy. So let me write example 2. Example 2. The multiplying out is the kind of easy part of the perfect square. This time we have a minus, but you still want to expand it first. Expand first. Okay, FOIL. So y times y squared. The outer, now you're gonna have to really watch these signs because I'm not doing a keep, change. When you FOIL, if you wanna keep, change here, if that helps you, that's fine. I'll leave that up to you, but I'm not gonna do it. So what you have to recognize is that the sign in front of the number goes with the number. So this subtraction sign in front of the 4 means that the 4 is negative. And this subtraction sign in front of the 4 means that the 4 is negative. So when I do the outer, I'm multiplying a negative 4 times a y. So it's negative 4y. The inner is negative 4 times y, which is also negative 4y. And then the last is negative 4 times negative 4, positive 16. So the sign, that's the sign in front of the number, tells you what sign it is. Like subtraction sign in front of the number means that number after it is negative. Adding like terms, minus 4y and minus 4y is minus 8y plus 16. Okay, let's do maybe 2 more of this kind. This guy, 6z minus 2y. So we're making them a little bit bigger now. Expanding 6z minus 2y times 6z minus 2y. Okay, then we're going to FOIL it. So we've got, the first is 6z times 6z, 36z squared. The outer, negative 2y times 6z. right? If you want to look at that separate, negative 2y times 6z. That's negative 12yz. The inner is also negative 2y times 6z. So see how the inner and the outer are actually the same? And then the last, negative 2y times negative 2y, right? Negative 2y times negative 2y. That's going to be a positive 4y squared. And I just ran out of room. Plus 4y squared. So adding like terms, 36z squared minus 24yz plus 4y squared. All right, and one more. 4. Let's do a little trickier one. Let's do it. Nah, let's go back to a simpler one. Let's just go p plus 6 squared. All right, so expand p plus 6, p plus 6, FOIL, p squared plus 6b plus 6p, plus last is 6 times 6, 36. P squared plus 12p plus 36. Okay, that's how you multiply. Pretty straightforward. Now we want to go the other direction, and we're going to factor. So squiggle line. This is where it gets a little trickier. Factoring perfect squares. Okay. So here, let's look at this pattern again. Do you remember our pattern went like this? A plus b squared, right? Which is a plus b times a plus b. When I FOIL it, it's a squared plus 2ab plus b squared, okay? And the minus version, a minus b squared. I know you already wrote this, but it's good to write it again. A minus b times a minus b is going to be a squared minus 2ab plus b squared. Okay, so we'll just have that there so we can look at it. Example 1. Y squared plus 6y plus 9. Now looking at this, first of all, I know if you were to think about special patterns, this couldn't be the difference of 2 squares because it has 1, 2, 3 terms. So this is what a perfect square looks like when it's unfactored, and we want to put it into the parentheses. The first thing you've got to do though, so step 1, test to see if it's a perfect square. You got to test it. Now, here's how you do it. Check the 2 ends first. The ends have to be perfect squares. So if you can write them like this, right? In other words, if you can take the square root of 9, if it has a square root, then write it in a parenthesis like that. Does y squared have a square root? Yes. So write it in a parenthesis like that. So step 2, see, or here, let me say, make sure first and last terms are perfect squares. The first and last have to be perfect squares. And they are, right? 9 has a square root. And if it's a perfect square, it has a square root. So write it in a parenthesis, right? So step 2 is good. Step 3. So what you're gonna do, I'll figure out how to word this in a minute. The next step is to multiply the parenthesis parts together. Multiply parenthesis parts together. Right, equals 3y. Then double it. Then double. Right, 3y times 2 is 6y. That should be the middle term. So if you multiply what's in the parentheses together and then double it, 3y times 2 is 6y, and that's what you have here. You put a check mark, the middle term checks out. Do you see how in the pattern here, the middle term, if you take the a and the b and multiply them, which is like the 3 and the y, you get ab. If you double it, 2ab, right? 2 times 3y, 6y. So middle term, I know this is confusing, but you'll get the hang of it when you do more examples. Middle term is twice the parenthesis pieces multiplied. That's not very technical, but that's what it is. Okay, middle term is twice the parenthesis. Now, if that checks out, so this is the test. If you've got these two and this check mark here, then here's what you do for the factors. You have the first piece here, take the first sign. So if this is a plus sign, this is a plus sign. Plus, plus, and then what's in the last parenthesis? 3. That is factored. Okay, I'm gonna break this up again. Sorry, there's so many parts to this, but I don't want to have a super long video.